What's going on, Algebra 1? It's time for our second video here. We got radicals day 2. We're going to talk about multiplying, we're going to talk about dividing. So hopefully you've got your note sheet in front of you, and let's get going. So on that first page there, we've got a warm-up at the top. I'll let you do that if you'd like, but I'm going to skip right to the box here, multiplication with radicals. So here's our rule for multiplication. We multiply the outsides by the outsides and the insides by the insides. So you got to know what I mean when I say outside. When I say outside, I'm talking about any number that's not underneath a square root or radical symbol. And when I'm talking inside, I mean the numbers literally inside the square root or radical symbol. So we literally do outside times outside, and then it becomes square root of inside times inside. And that's how you multiply radicals. And what you'll notice here is there's no addition, no subtraction. It's 6 times square root of 2 times 4 times square root of 14. So you multiply the numbers that are in the same form as each other. So 6 times 4 would be 24. Square root of 2 times 14 would be 28. And then step 2 is to simplify. So then I have to look at my radical, square root of 28, and see if it simplifies. I know that 4 goes into 28. So this is going to become 24 times the square root of 4 times the square root of 7. 28 is 4 times 7, right? So now I have 24 times 2, root 7. And 24 times 2 is 48. So my answer here is 48 root 7. So I've got a couple examples here already started or finished. If you look at A, example 1, problem A, you can kind of fill this in as I talk about it. Outside numbers, 8 and 5. So I multiply them together, 8 times 5. You don't really have to write this stuff down. You know what 8 times 5 is, it's 40. Okay? Square root of 3, square root of 2. Those are my inside ones. I'm going to multiply them together and go to square root of 6. So, you would probably do this problem by going straight to 40 root 6. It's pretty fast. Outside times outside, inside times inside. Let's look at problem B. A little note here. Simplify first, if possible. So any square roots that you see that you can simplify, we should do that first before we do our outside times outside, inside times inside. And the reason is, look, square root of 12, I can write that as root 4, root 3, and that square root of 4 is going to become 2. And square root of 4 is 2. So what I'm going to be doing here is making my life easier, right? 6 times square root of 4 is really 6 times 2. So I know that that becomes 12, root 3. 2 times 2 is 4. And now I have outside numbers still, so I need to multiply them together. Notice this is all still multiplication. So now I get 48. 12 times 4 is 48, root 3. And that's my final answer. You would get the same thing, but I'm going to show you exactly, it's going to be a lot more work to do it without simplifying first. So there, look, I mean, maybe it's not quite more work, maybe it's about the same, but the numbers could get pretty big. 48 was one we were pretty familiar with at 16 times 3. But if we ended up with a lot bigger number, it would make sense to make sure you simplify first. So as a general rule, I say simplify first. All right, let's see what else. Problem C. Okay. The parentheses mean multiplication. Problem C is no different than problem B. We have 4 root 2 times 3 root 2. So I'm going to do outsides times outsides. That's going to be 4 times 3 gives me 12. Root inside times inside. 2 times 2 is 4. Now I try to simplify. Square root of 4. Hey, I know that's 2. 12 times 2. So my answer here is 24. Right. Moving on. Problem D says 5 root 3 squared. Okay. This means 5 root 3 times itself. So write it out. 5 root 3, 5 root 3. Okay, there's no addition symbols, there's no distributing, it's just 5 root 3 times itself. And now I have outsides, 5 and 5 is 25. times insides. Square root of 3, square root of 3 would be square root of 9, which is just 3. So this is 25 times 3, which is 75. So what I want you to do now is pause the video and try E and F on your own. With E, simplify first. With F, make sure you write it out as negative 6 root 10 times negative 6 root 10. So pause the video and compare your answers with me. Okay, let's take a look and kind of compare. C on problem E, I bet some of you didn't simplify first, and it was probably harder and bigger numbers. If you simplify it first and remember to keep everything multiplication, it works out to be a pretty nice problem. Same with F, make sure your negative times negative is positive 36. And all right, let's move on here. So the next kind of multiplication we're going to do is distributing. So now we're going to see some problems that actually do have addition or subtraction involved. So let's kind of do this example together here. We've got a square root of 10, parentheses, 2 plus root 5. So I can't remember, you can't combine like term or a non-radical number with a radical number. So we can't simplify the parentheses, so we just have to distribute. And here we have to remember our multiplication rules. 2 is an outside number, 10 is an inside number. So I'm going to write this first multiplication as 2 root 10. That's it. You don't even have to do any math. You just squeeze them together. Okay, and then I'm going to multiply root 10 times root 5. Well, it's going to be positive, and I get, these are inside numbers, so I have to multiply them together. 10 times 5 is 50, so I get root 50. Then I have to simplify. Root 10 doesn't, so I'm good with 2 root 10. But root 50, I'm thinking root 25 root 2, which is 5 root 2. I would then check, do I have like terms this time? Nope. So now that's my final answer. So if you flip over to the back here, I'll move over, we've got some examples. Example 2a, I've already done. When you distribute the 5 times 2 is 10. Here I have 5 times 3 root 3. The 5 and the 3 are outside, so I multiply those together. So that's where we get 15, and the root 3 didn't have anything to multiply with, so it stays, root 3. So your answer is just 10 plus 15 root 3. So let's try B. I have 6, and I'm multiplying it by root 7 minus root 10. There's 7 and the 10 are inside, 6 is outside. So when I multiply, I just squeeze them together. I get 6 root 7 minus 6 root 10. I check, can I simplify? But 7 and 10 do not simplify. They're not like terms, so we are done. So now take a second and try C on your own. Pause the video. C is pretty straightforward. Root 3 times 1 is just root 3, plus root 3 times root 2 gives you root 6. D, E, and F, we get a little more challenging. So let's just sort of talk through D. I've already got it written down, so you can copy it down as we go here. I'm distributing negative root 2. So I got to watch out for my negative sign. Negative times positive will give me negative. Inside, there's root 6. 2 times 3. Then when I do negative times negative here, that gives me positive. And I get inside gives me 20. So I have negative root 6 plus root 20. Root 20 would simplify. So root 20 is 4 and 5. So I can do square root of 4 is 2. So I get a final answer of negative root 6 plus 2 root 5. Those are not like terms, so I can't add them together. That's just it. You leave it right there. All right, let's take a look at F. I'm going to have you guys try it, but I gave you a little hint to start. 2 root 2 times 3, we'd get 6 root 2, because I do the outsides, the 2 and the 3. So then I'm going to have minus. You finish this off. All right, check your answer, see how you did. And then we got to move on to some bigger distributing. Okay, so what if we have a binomial times a binomial? Right. We have to do, I know I've called it double distributing, maybe you just have to distribute both the 2 and the root 6. And a lot of times what happens is you just get these kind of 4 different terms that end up not combining, but we do have to simplify. So like when I get the root 6 times root 3 gave me root 18, so I have to think about that as root 9 root 2 is 3 root 2. Okay, this one, no like terms, so we're done. Sometimes though, we'll get like terms, and that actually makes our life kind of nice. So in example 3 here, problem A, we're going to distribute the 2 first. So when you distribute that 2, we're going to get 4. 2 times 2 is 4. Then I distribute the 2 to the root 3, and I get 2 root 3. Then I'm going to get minus 2 root 3. And finally, minus root 9. The middle terms cancel out. Check it out. And we also have that root 9 is just 3. So we get 4 minus 3, which is just 1. Let's try B. We start with 4 times 8. That's 32. We do 4 times root 2. 4 root 2. Negative root 2 times 8 would be minus 8 root 2. And then negative root 2 times root 2 would be negative root 4. We want to start getting into that habit of, that's just 2. So I would go straight to 2 there probably. So we have 32. These are like terms, so I'm going to combine them. 4 root 2 minus 8 root 2 would be negative 4 root 2. Minus root 4 would be minus 2. And then I do 32 minus 2, and I get 30 minus 4 root 2. 30 minus 4 root 2. And that's my final answer. All right, using A and B as a guide, I want you to try problem C on your own. And pause it, check your answer with me in a second. So you should get 35 plus 28 root 5. I'm going to move on to division now. I know we have some problems left on this page. You can try those out if you want and check your answers on the note sheet answer key. For division, okay, there's kind of a key idea that we need to remember, and that's up at the top. I've written at the top of this page here. Maybe you can copy that down. When you square root a fraction, you can split the square root up into the top and the bottom. Okay, and in either of these cases, we could simplify the fraction. And so if you had something like square root of 9 over 16, you can do square root of the top, square root of the bottom, you get 3 over 4. Okay, so I think actually doing a couple problems is more beneficial than talking through this box here for this type of problem. But one pattern that I want to, again, point out is this one right here. So square root times itself just becomes that number. Root 2 times root 2 is 2. Root 3 times root 3 is 3. Root 327 times root 327, it's just 327. Root smiley face times root smiley face is smiley face. Okay, and we use that to our advantage here. So rationalizing the denominator. When you have a fraction, we're not allowed to have a square root in the bottom. Okay, it's like bad math manners. And so we do this thing called rationalizing it to get the square root out of the bottom. And it's really simple. All you do is multiply the fraction by whatever the square root is to the top and the bottom. What do I mean by that? What I mean is if I have square root of 3 in the bottom, I'm going to multiply the top and the bottom by square root of 3. And if you notice, what I'm doing on the bottom is creating that pattern here. Root 3 times root 3 is just going to be 3. So by doing that, I get 3 on the bottom. There's no more square root in the denominator. That's great. On the top, I just do 2 times root 3, and I get 2 root 3. So that's how you do a problem like this. Square root in the bottom, you just multiply the top and the bottom by that square root. So let's look at the second one. Problem B. I'm going to multiply the top and the bottom by root 5. On the top, I'm going to get 7 root 5. And on the bottom, I'm going to just get 5. Root 5 times root 5 is just 5. We could go through that whole process of root 25, and then that's 5. But the idea is the pattern says we'll just get the number inside. So pause it and try C. Right? Did you multiply the top and the bottom by square root of 2? And then you would get 3 root 2 on the top and 2 on the bottom. So again, in the interest of time, I'm going to skip through a few things. But if you look at problem D, square root of 9, that's a freebie. We should simplify that to 3 first. In G, square root of 25 is 5. Let's simplify that first. Okay, so we get in G 100 over 5, which is just 20. Boom, done. A problem like H, where I have square root of 12. It's a good idea to try to simplify first. So square root of 12, I'm thinking root 4, root 3. So this is really 1 over 2 root 3. And now the square root in the bottom that I multiply by is just root 3. Root 3, root 3. I do that to the top and the bottom. The top, I just get root 3. And the bottom, I'm going to get 2 times 3. Because root 3 times root 3 is just 3. 2 times 3 is 6, so here I get root 3 over 6. Great. Almost done here. Let's go to the last page. So just a few more examples, and the emphasis on this page is to simplify and reduce first. So a problem like A, it's root 3 over 5, where the square root's the whole fraction, so you just split it up into root 3 over root 5. And now my square root in the bottom is root 5, so I'm going to multiply that to the top and the bottom. On the top, now I have inside one, so I get root 15 over root 5 times root 5 is just 5. So that's my final answer. Okay. You try B here, split it up, root 2 over root 7, and what would you multiply by on the top and the bottom? Hopefully you picked root 7, and on the top we get root 14, and on the bottom we just get 7. We're done there. When you have a square root number and a regular non-square root number, we can't divide that. We can't get 2 for this answer. That's it. Okay. C's got a freebie hiding in there. Do you see that square root of 16? Okay. D and E are examples of ones where we can actually reduce them, right? In your head, you would kind of do, okay, I can make this backwards. I can go root of the fraction 8 over 6, and I can divide them both by what? 2. So that becomes root 4 over root 3. Well, root 4 is just 2, so now it's 2 over root 3. And if I take 2 over root 3, I need to multiply it by root 3 on the bottom, root 3 on the top, and I get 2 root 3 over 3. Okay. Reduce the fraction first. You don't really need to write this step. What I can do is just reduce it from right here. So these both divide by 3. And I get root 2 divided by root 1. And the square root of 1 is just 1. So I just get root 2. All right, in the interest of time, I'm going to just kind of show you some of the remaining answers here. You can copy them down now. You can go to the notes answer key and get them copied down. Mostly, we want to focus on the ones we actually went through in this video. The other ones, they get a little trickier, and we'll practice them and we'll get better at them as we go, but they involve maybe reducing on the outside, things like that, simplifying a little bit more as you go. Okay, so thank you for watching, and let's see, here's answers to JKL. Again, rewind, pause, whatever you need to, and good luck.